नीलोत्पलदलाभासः सामवेदो हयाननः अक्षमालान्वितो दक्षे वामे कम्बुधरः स्मृतः ॐ नमः सामवेदाय ॐ नामस्तौ होग्नायि ओजसाय गृणान्तायिदे वाकृष्टया अमायेः आमाउहो वा त्रमर्दया दूतां वोः विश्ववेदसां हव्यवहाम् आमार्तायां याजिष्ठं जसेहाय गिरा औहो वा होई डा उपत्वाजा मायोगी राओयायु दाइदी शतीर्हविष्कृता ओयायु वायोरानी कायास्थायिरान् अश्वागावा उपत्वाजामायो गिराः दाइदिश ताइः हाविष्कारताः वायोरनाहायिकाया स्थायिरा औहो वा ईडा हाउ 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 भ्राजा ओवा भ्राजा ओवा भ्राजा ओवा अग्निर्मूर्धादिवाः काकूत पतिः पृथिवीयायाम् अपाङ्ग्रेतांसि जायिन्वाति हाउ 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 भ्राजा ओवा भ्राजा ओवा भ्राजा ओवा ये विश्वस्य जगतो ज्योतिः ॐ. This was some samaganas I chose for various reasons. One is it's a stuti on Agni, and samagana is also less heard usually, but there is lot of priyata in samagana for many of the devatas. So it's a prayer for Agni Devata, where he is considered as a Vishwa Vedasam. So that is one of the Visheshanams used. Vishwa Vedasam, he knows that which is born and whatever is available in the world. So since we are here as part of Jnanam Vijnanam National Science Day, I thought this will be appropriate. In fact, there is a stobha there, Jyotihi also. And since lot of the discussion is all surrounded on astronomy also, it seemed apt to choose this.
Shri Gurubhyo Namaha. Namaskar to one and all. It's indeed my great pleasure to welcome you all on this unique celebration of IKS National Science Day, which is done with the support of the IKS cell of Ministry of Education in conjunction with the Atharva Forum. In the Atharva Forum, we have featured several science-related topics, and it gives me immense pleasure to thank from this platform to Professor M.D. Srinivas, who has also featured in the Atharva Forum earlier, who has been conferred with the Padma Shri Award this year. We have gathered today to celebrate the IKS National Science Day by discussing topics that are not only from the traditional Indian heritage, but also have immense contemporary relevance. And for other details, we have partly covered few talks in the Atharva Forum channel. I welcome you all once again and request you to subscribe Atharva Forum YouTube channel. I wish the proceedings of the day and the celebration goes well. Namaste.
Thank you, Professor Ramanathan. The first session will be a discussion come interview with Professor MS Sriram. A brief introduction to Professor MS Sriram. He did his BSc Honours in Physics from Bengaluru University in 1969 and MSc in Physics from IIT Kanpur in 1971. He completed his PhD in Theoretical Physics in 1978 from IIT Kanpur. He worked in the University of Allahabad for 5 years before joining the University of Madras, from where he retired as the professor and head in 2011. Currently, he is with the Professor K.V. Sharma Research Foundation, Chennai. Apart from his research in physics, he has been working in the field of Indian astronomy and mathematics for nearly 34 years. He has published several papers on Indian astronomy and mathematics and also 3 important texts of Kerala School of Astronomy and Mathematics, namely Yuktibhasha, Tantrasangraha and Karanapaddhati, as co-authoring the books with other scholars. Recently, he has completed a book on Siddhanta Shiromani, a major work of Bhaskaracharya, and is working on 2 Kerala texts on astronomy. He was elected as a Fellow of Indian National Science Academy, INSA, recently for his contributions in the area of Indian astronomy and mathematics. Welcome you, sir, to the session today. Since you are well known for the Kerala School of Astronomy, I would like to begin with this. It has gotten popular in the last few decades. Can you briefly explain to us how you got involved in this work? Because this parampara was less known during that time, and any unique aspects of this parampara that you would like to highlight for us at this occasion of National Science Day also.
Thank you. Thank you. See, around 1980 or so, we were some of us, means myself and some of friends and all that, in Chennai to start with, and then other places also. We were, somewhat dissatisfied with the kind of science and technology development that is taking place in the country. I mean, not only we, and many others would have been dissatisfied. So we were didn't know how it actually is relevant to the Indian society as such, and that also made us think, question what was the tradition of science and technology in the country earlier, before British came and all that, the indigenous tradition of science technology. So this, of course, lot of studies, etc. happened. There were some discussion groups in several centers in India. I will not go into the detail. Specifically, around 1991, so we had a coordinated project on something like Indian Theoretical Sciences, you can say, supported by DST, Department of Science and Technology, which covered Indian astronomy, mathematics, Vyakaran, law and linguistics and philosophy, especially Navya Nyaya and so on, you see. So this coordinated project was there, and in Chennai itself there were 4 places, that is IIT Madras, then MIT Krompet Chennai, so then Madras University, in which myself and MD Srinivas were situated. I am talking of 1991, okay. And then well, PPST itself has this thing, base, has some kind of office and all that. So this our department, theoretical physics department, took up astronomy, okay. Title of the topic was Accuracy and Optimality of Algorithms in Indian Astronomy. So that's the topic. Somewhat related to that was the project on proofs in Indian mathematics for PhD Foundation, which was principal investigator, which was none other than Professor K.V. Sharma. So these are the 2 which are somewhat relevant to our discussion today. So in this accuracy and optimality, so we thought how good is the Panchanga. A lot of people, Indians also prepare Panchangas, manuals and almanacs, you see. So how good are they? How accurate are they? So that is the question we are facing. So we thought that we should go into the actual calculations of the planetary positions, eclipses, and all that in Indian texts. Okay. So we began with the texts which are considered were Aryabhatiya, that is about 499 CE. So then Brahmasphutasiddhanta Khandakhadyaka, both by Brahmagupta, which is around 720. Bhaskaracharya Siddhanta Shiromani, that's around 1150. And Kerala text, Tantrasangraha, and also some updated version of that called Siddhanta Darpada. So that was around 1500 on afterwards. Okay. So these are two Kerala texts. And then Karanapaddhati also, I think we made some analysis. And lastly, what can be considered the greatest, last great work on Indian astronomical tradition. So that is Siddhanta Darpada by the Varya astronomer Chandrashekhar Singh Samanta. Okay. So that he wrote it in around 1860 or so it is published. Okay. So I was the investigator, principal investigator. Ram Subramaniam just then joined us. He joined as a project associate. Okay. And MD Srinivas was some kind of a consultant. So now, we went through the calculations of the, specifically, not the whole text. We didn't study all these texts. It would have been very difficult. The calculation of the planetary positions in these texts. Surya Siddhanta, I forgot to mention Surya Siddhanta because Surya Siddhanta is immensely popular even now. So all these texts, how are they calculated and how good are they? So we straight away got into that, using these things. And then when we came to Tantrasangraha, so we had to see what is written there and what it says about it. We saw that there is even a change in terminology. See, earlier what used to be considered, I don't want to go into technical details, Mercury and Venus were treated in a certain fashion in the ancient texts. And similarly in Greek tradition also it was like that. And you have to apply some correction to it, to the mean longitude, mean position, to get the correct longitude. So there was some problem. It didn't correspond to anything physical. But Indians were following that. But there was something with the latitude of the moon and the planets, which was giving the correct result. Okay, and they were doing the correct thing for this Mercury and Venus, at least the correct formulation. So this dichotomy was there in the earlier tradition before Tantrasangraha. And we saw that Nilakantha Somayaji changed the terminology itself in the very beginning in Madhyamadikara. He says, that the revolution numbers for Buddha and Shigra are what are listed as the heliocentric revolution numbers. Earlier they used to be considered the Shigrochas, Don't worry about the technical details, okay. And then afterwards we saw that the one particular correction which was applied to the Mercury and Venus, which caused a lot of problems even in the Greek tradition. So this was done in an entirely different manner by Nilakantha Somayaji. You see, he says, that what you are talking of Shigrocha, he's saying what was considered as Shigrocha of Mercury and Venus in the older tradition is actually the Mercury and Venus itself. And he says that the sun is the Shigrocha for all the planets. So he is coming with a new formulation, and equation center has to be applied this way. And he gave the correct way of applying the what we know as the correct way. For the first time in the history of astronomy, he did that. And he went on to propose a model in which, this is in Tantrasangraha, okay, in which the planets move around, a geometrical model in which planets move around the sun and sun itself moves around the earth. You can call it as some kind of a quasi-heliocentric model. So these are the model he gave, and immediately, of course, though our task was to find out the accuracy and all that, immediately we got into that because he is saying something very significant. So we also got into some various other texts works by Nilakantha, like Aryabhatiya Bhashya, Siddhanta Darpana, Golasara, and later, some other, texts, some small works and all that. And so we published a paper also in Current Science. It was very interesting because we thought that this is something which will interest the general scientific audience in the country. So that's why we said Current Science is some kind of a semi-popular journal published from Bangalore. So we thought that it will interest the general this things, scientific community, especially physics community in this country. Okay, after a long referee battle, that anyway we leave it. But there was a loud silence. Only one or two people, responded positively to that. One of them was, of course, Professor Rodham Narasimha, who is he died recently. That is how we got into that. Okay, and then of course we published we completed the report on the. We came back to the regular, calculation of the accuracy and optimality of Indian algorithms. Okay, so that was around 94. We published. Project was completed. Then after some for 1 year or so, of course, Ram Subramaniam, we are depending heavily. He was the Sanskrit expert. For 1 year or so, he was some kind of a gentleman at large. And then we thought that myself and MD Srinivas, we thought that okay, he is so good in Sanskrit, and he is a these things, computation, these things, he knows physics also well. He can pick it up. So it is better that he does a regular PhD in regular physics. Okay, that is what he did with me around from 95 to 2000 or so. And then, but we were also giving lectures and various Kerala tradition and all that kind of a thing. Then immediately after that, after his PhD in theoretical physics with me, so in 2000 we took up this Tantrasangraha. So because 2000 was a very important year, because that was the 500th anniversary of Tantrasangraha, as well as the 1500th anniversary of Aryabhatiya. So we had a conference and a lot of people came and presented their papers in not only the Nilakantha's works, but many other works, Kerala works, and also other Indian works also. Okay, and in fact, two people came from Iran also. So they talked about the Iranian tradition in astronomy and so on. Okay, so after doing this Tantrasangraha, this conference, we thought that we should, we are just talking about it only some particular aspect we are doing. So we should get into this Tantrasangraha fully. So fully we should study and translate and make explanatory notes. So that's what we did that. So for nearly 3.5-4 years, we did Tantrasangraha. And meanwhile, Professor K.V. Sharma had done this project on proofs in Indian mathematics from 91 to 94. So that also was incomplete. It was preliminary work, you can say. He had done the translation, but lot more needed to be done. So that was, it so turned out that his work was completely on Yuktibhasha, another Kerala text. So it is completely devoted to proofs in Indian mathematics and astronomy. So now for some time, of this Tantrasangraha, Yuktibhasha, we kept on, both we studied together kind of a thing, because they are in, Yuktibhasha is actually supposed to be a commentary on Tantrasangraha. So these two Kerala texts we intensely studied, and and just around 2007 or so, Venkateshwar Pai joined Ram Subramaniam in IIT Bombay. So as a PhD student, he did work on Karanapaddhati, another important text of Indian Kerala text. Okay, and he has got some very novel features and all that. So these three works were going on, you see. So almost overlapping kind of a thing. So and afterwards, of course, Karanapaddhati, we took it. He did only a part of Karanapaddhati for thesis. So we went on in detail regarding Karanapaddhati also after publishing Tantrasangraha and Yuktibhasha. So these are this Kerala tradition, we studied in detail. These are the three texts we discussed, because these three texts were mentioned by one George Fish even in 1838, 1834 or so. He was a British official. So he had mentioned these things. So it was appropriate that we discuss these, which are considered as important. So these texts we considered, and of course now it is going on more kinds of works on Kerala, because we thought that as we have also already seen that some new things are there. Apart from astronomy, mathematics, people know about the infinite series for pi, sine, cosine functions, in Yuktibhasha. So these are all important things. So we should concentrate on Kerala for astronomy, mathematics for some time. So they went on like that. Okay, so that is how we got into that, and now we are of course taking some more works related to. Yeah.
Thank you, sir. Thank you very much. Since you started the explanation, we know that Panchangam is one of the main concerns of all these calculations. For a lay person, we hear a lot of terms like Vakya-panchangam is one. There are other kinds of Panchangam. There are differences in computations, etc. So, what is essentially Vakya-panchangam? In fact, there is going to be a discussion about some aspects of this later in the discussion. So, what is a Vakya-panchangam, and what is the difference between others and this?
Yeah. So Vakya-panchangam, you can say it's some kind of a subset of Indian astronomical tradition, which is longitudes, positions of the planets, okay, in a particular manner. So it will give some mnemonic which will help you to calculate the positions of sun, moon and all that time using these remembered verses, okay, remembered phrases, okay, and then do some small arithmetical calculation, okay. So you don't have to do know the whole jing bang of Siddhanta and all that to do astronomy calculations using Vakya-panchangam, okay. So Vakya-panchangam, it was actually traced back even to some 6th, 7th century and all that, related to Bhararuchi and so on, okay. He gave some 248 Vakyas for moon. But one should understand that for some time this is particularly prevalent in Kerala and Tamil Nadu, okay. In fact, it is good that today's session they will talk about how it was there in Tamil Nadu, even Tamil region, even little earlier than the standard text and Vakya called Vakya-karana. You see, probably it was some kind of systematization was started in this thing. Anyway, so that's that apart. So this gives some simplified way of doing things, but the model is the same. You see, so normally in Siddhantas you consider you will have a model, some kind of a model for calculating positions of planets. Okay, so you will have this Kaksha Mandala, then Prati Mandala, the Mandanitocha Vrutta, and other using all these things you will calculate the positions of the planet. So here all these are imbibed, they are incorporated, they use the calculations. In fact, we have checked that what these Vakyas, okay, Girnaha, Shreyaha, that is the Vakya for, it stands for the longitude of moon on first day of a cycle. So that is, and you have to add something, okay, so, and then it gives some 247 more Vakyas, okay. So that is all completely based on what can be considered as a standard Indian model, essentially Aryabhata model, okay. It's completely based on that, but it gives only the final results kind of a thing. And you have to do a little more to get for any particular day. Why 248? Because I don't want to go into technical details, the so-called moon's anomaly cycle. You see, modern people know that it moves in an elliptical orbit in modern astronomy, around the Earth. But actually, this elliptical nature was simulated by a circle only, but an eccentric circle, which is not centered around Earth but something else. Okay, so that eccentric circle, okay, so that is the moon is moving, and there is one direction. You see, what is considered as the major can be considered as the major axis in Kepler's astronomy. So that is the direction is called apogee. That apogee or mandocha. So that direction. That mandocha keeps changing for the sun. Moon has a period of 27.3 etc. sidereal period, but my lunar month is slightly more, 29.5 days, and these anomaly cycle, when do the moon and its apogee are in the same direction. So that is, then it will be like, in 248 days there will be 9 cycles. So this anomaly period will be 248 by 9. So there is some advantage in that, because this will determine the calculation, true longitude and all that. So this 248 day cycle, so there are 248 Vakyas. You see, that is what the Vakya text says. So for sun it is even simpler, okay. Sun, because sun there is it is simpler, and there is anomalies that apogee is constant. For planets it is more complicated, because it has not only mean planet and then what is known as the Mandocha and then what is known as Shigrocha, that is sun. So to have perfect alignment, all the three should be in the same direction. So that will be happen in only some yuga or so, for 43 lakh years or something like that. See, that is of no use for any calculation. So they have some approximation schemes and all that. So for the planets, they have what is known as Samudra Vakyas or Kujadi Vakyas and all that. But all based on this thing, Indian text. But it has, one can do without referring to the Siddhanta text. Okay, without referring to that, if you know this thing, so this is what you can do. Okay, कुछ से इसका कुछ calculation बन जाता है. So arithmetical manipulation बन जाता है. So with that you can do. So using some essentially arithmetical calculation you could do. How does he do it? Probably he did the Vakya method. He knew already all that was imbibed in his mind, the Vakyas, and then use some small, little more calculation is done to calculate the positions of these things or eclipses and all that. You see. So that is the greatness of this method. So, but it is based on the Siddhanta. But it is somewhat, and even now people they say, especially in South, they say that this is based on Vakya-panchangam. This is the Vakya method, which has its own characteristics, which is simplified, but based on the main Siddhantic tradition. Yeah.
Thank you, sir. In fact, that anecdote was quite interesting about that Kauri, because there was recently a research paper, where they discussed about how children in mathematics fare compared to children who are working in shops, normal shops who do mental calculation. So they are able to process it so fast, but the same without paper and pencil, the school children were not able to do. So it's a very recent paper. So in fact, National Science Day, I think those small points are also extremely relevant.
Yeah, just a quick thing about this remark. We have got one, of course, greatly interested in Indian science and technology and all that, in a way, alternate technology, one Ashok Junjunwala. He is quite well known. Because basically a technologist. He's a Marwadi. So he said that, he said that, Marwadis have a own way of checking the calculations and all that, kind of a thing. So that must be based on this kind of traditional methods of computations. Yeah.
In fact, we were searching for some such tables also. There were ready-made tables.
Yeah.
This is also a kind of table only in one sense.
Yeah. Tables, basically tables, yes. Correct, yeah.
Okay. You also mentioned the Siddhanta, right? Siddhanta, based on that, this is a easy way of computation.
Yeah.
So, thinking about the Siddhanta itself, right from Aryabhatiyam, etc., it is known that the constants need to be updated. There are several parishkaras that happened and so on. But now, when we think about the Panchangam, generally, if we go and talk to several people, I may not know all, but it is found that they are using ephemeris and some other hybrid kind of computation, etc. So, there is always a natural question as to whether we can have a up-to-date Siddhanta and our own method of entirely doing the Panchangam with that. So, what is the current state of Panchangam in our country, and whether a new Siddhanta based on the principles of old can be done? Or is it done already, because we are not aware?
Well, the Panchangas, I have met long back only. I met some Panchanga Kartas and all that, long back, nearly maybe even 35 years back or so. I could not get a definite this thing, but I got the impression that they do use the Indian astronomical ephemeris called Rashtriya Panchanga, which is published by the government of India. Okay, it has been published for many years, more than 50 years. So, and they do the calculations according to the modern methods. I don't know what exactly they do. I mean, what the exact procedure, but certainly I believe, no, they would have done this, actual calculations using, this celestial mechanics and all that. And probably many of these packages they might have got from other countries also. I don't know really. I have to talk to them and not this thing. So they essentially they do according to modern calculation, and then they do some of these things they cast in the Indian framework, okay, like Nirayana longitudes, okay, Nirayana grahas, okay, because in Indian zodiac the 0 point is the Meshadi, which is about 24 degrees from the vernal equinox, okay. So if you measure the longitude from that, that's called a Nirayana graha, okay. So Nirayana graha the list and all that, and also they give the Tithis, Nakshatras, Karanas and all that, So that is exactly the same, that is all astronomical significance. Tithi means, the time interval in which, the sun and moon separate by 12 degrees viewed from the earth, okay. So that is just a physical thing, which is called Tithi in India, okay. So they give the Tithis and all that kind of a thing, but all using modern methods, I think, yeah. So now your question is good. In fact, we also almost got into that this problem in this issue when we was doing that, this algorithmic calculations of the Indian longitudes and all that, planetary positions during 1994. Okay, so we in fact, but we stopped at the recent dates. We saw recent dates using a epoch is the epoch if it is nearby, then of course calculations will be error accumulation will be less. Okay, for instance, if you take the initial values given observed values as something like 2025, January 1st or so then naturally that initial error will not be there, so the errors will be much reduced. So that's something like that we did, but his question is somewhat different, that using the Indian methods only can we do the fairly accurate values of the basic. Okay, for instance, for moon, so there are apparently there is some, I have not seen them, but moon is influenced by basically Earth, Earth's gravitation, and then it is influenced by Sun's gravitation also. You see, so it's called perturbation in modern celestial mechanics, and then it is known that it is influenced by Jupiter also. Jupiter is a big object, okay, though it is at a distance. So yeah, all these perturbations etc. are taken into account in the modern celestial mechanics. Okay, so there are huge there is huge amount of work in Europe, after Newton about celestial mechanics. You see, they wanted to improve the methods for planetary calculations. That's why they predicted Uranus, I think, was predicted using this, and it was exactly at the same position. So that is when this tremendous faith in classical mechanics, began. Okay, anyway, so that is their method, and there was Brown's lunar theory and all that are fairly complicated things. So now, if you just take 1500 terms and just put it in some Sanskrit sloka, you see, that is not the in spirit of Indian mathematics. Okay, Indian mathematics, Indian astronomy, moon, for calculating moon, there are two corrections. One, the basic thing is called what is the mean longitude. Suppose it is moving uniformly, iska position kya hoga? So that's called Madhyama Graha. And then one more correction, so that's called the Manda Samskara. So Manda Sputa comes, and then later, after around the period of Laghumanasa, one has one more correction called the evection term. So that also is included in this. So normally these things in evection term is not considered in many calculations. Evection can be so happen that it doesn't contribute to eclipse calculations. You see, it vanishes in that. So evection also is there. So now, if you do with these three terms for moon, so then you can say it is the Indian method. But if you take hundreds of terms, it may not be called the Indian method. But it is permitted, some 2, 3, because Indians were evolving. You see, let us get it clear, I mean, in spite of all this, tremendous propaganda against, the static nature of Indian astronomy and all that, there was considerable amount of advancement. They were revising parameters all the time. Okay, they were revising parameters and all that. But the framework was slightly somewhat fixed, and it didn't evolve too much after Nilakantha Somayaji. So, see, one or two terms, 3-4 terms, if you take that, that can be considered still as this thing, and that is what Chandrashekhar Singh Samanta does. He has got about 5-6 terms in his, per moon. So that, and he did everything. Probably he was aware of the European tradition, because already British rule was well established, and he knew quite a bit about European astronomy. He also considered some 3-4 more corrections, annual equation, variation and all that, and he gets better results. And apparently the Panchanga, which is published by this Puri temple, is based on Siddhanta Darpana of Chandrashekhar Singh Samanta. Okay, so that kind of a thing is allowed. So with that kind of a thing, are you getting very real, accurate thing? So that I think some analysis has to be done. I think it is possible, and I think it is a very good question. Some of my friends in Bangalore addressed that, not in our group, but they have done, this. They say that they've changed the parameters and all that, and so that the tally with the modern values is even better. But I have not gone into details about this. I mean, I have not gone into details of their calculations and their published books also, on Balachandra Rao and his disciples. So they do that. So one has to examine, but probably my impression is that they may have to be doing somewhat mechanically. Because see, certain things we have to do straight away. Like Indian solar sidereally, they don't consider the topic. Sidereally itself, year itself is slightly off. It is 365.2564 days according to modern. In Indian Siddhanta, 365.258 something. So that certainly needs to be changed. The parameter needs to be changed. Similarly, moon. So even if you change this simply, these parameters, you will have much better fashion. But if you change even more, it's a little more corrections for moon and all that, you can claim it to be in Indian tradition, and then I'm sure, and that is an optimism based on experience, and so you will get good results. So based on entirely an Indian Siddhantic tradition. So because it always said that you can borrow from others. That is the impression one gets from reading those books, the Siddhantas. So it is allowed. So one could have much better values in the framework of the Indian Siddhantas. Panchangas can be improved. Thank you. Yeah.
Thank you, sir. That was very interesting actually, because I have never heard that kind of perspective before. Now, going back a little bit into history of science, like you said, constants were being revised, etc. You have worked a lot on Bhaskaracharya's Siddhanta Shiromani.
Yeah.
So, what is the uniqueness of this, and how did it impact later parampara in India?
Yeah. Okay. That's a good question. You see, Bhaskaracharya Siddhanta Shiromani, I mean, this is a very well-known text. I mean, hundreds of people have worked on that, okay, and they have got great insights. There is no doubt about it. Lots of people have worked on, Bapu Deva Shastri, Sudhakar Dwivedi, you name anybody, see, they have all, in fact, anybody, even Western scholars of Indian astronomy, they have to look at Siddhanta Shiromani because it is an important text, okay. And people have written commentaries on that. Lot of commentaries are in Hindi also. My feeling was that this Vasana Bhashya of Siddhanta Shiromani has to be studied in great detail. It has to be translated completely. So the verses we confined ourselves to what is known as planetary competitions, Graha Ganitadhyaya. Okay. So in Graha Ganitadhyaya, about 462 verses are there, and Bhaskara has given Vasana his own commentary for all the things. Okay. So we thought that we should, to get the complete picture of Bhaskara's method, Bhaskara's way of looking at things, we have to completely translate the Vasana Bhashya also. So, fortunately, I had the assistance of Venkateshwar Pai and one lady, Sita Sundaram from Chennai. So, so they are good at Sanskrit. So they did the translation. Of course, I could check a little bit. So translation was possible, okay, of the whole Vasana. It took a long time, okay. We started in 2012, but of course, we are busy with other things. That's why it has got delayed. So complete Vasana has been translated, and it is very, very revealing, because Bhaskara, it is not for nothing that in all these Jyotisha Shastra centers in India, it is Bhaskara's work which is studied. Sampurnanand Sanskrit University ho, or Rashtriya Samskrit Vidyapita, Tirupati ho, wherever. See these, because his brilliance was well known. He explained things correctly and all that. He went into details of that, it's very, very revealing, and his important results are all very well known, his preliminary calculus results and so on and so forth, okay. But the way he explains everything, so that is very, very important and very educative, okay. In fact, I had looked at another commentary, astronomy commentary, that is Yuktibhasha itself. That is, most people, when they say Yuktibhasha, they look at only the mathematics portion. I don't know whether anybody has looked at our Yuktibhasha astronomy portion. So I was completely conversant with that, and that's done with Ram Subramaniam, MD Srinivas, okay, with translation and edition by K.V. Sharma, okay. So I was completely familiar with that, but this is, this is something else, because Yuktibhasha astronomy portion is somewhat dry, he's more close to a textbook in more modern thing. It's more close to that. But this Bhaskara, you see, he has got great poetical ability. Everybody knows, everybody knows, jump 50 feet upward, Nilavati. So in Siddhanta Shiromani, that scope is not there because the astronomy text, okay. But even then, so shlokas and all that very good. In the Vasana Bhashya, he explains everything, okay, from the first principles. So his views on that, So particularly noteworthy are, which is I had not seen earlier, but many people, there may be in other texts. He says all these parameters are there, Anand also mentioned it, okay, the Chigrocha, Mandocha, this parameter, that parameter. How do you measure it experimentally? How do you observe it? So Bhaskara has given the great detail. He describes these things are, how the revolution numbers of planets are obtained, how this Mandocha is obtained, how, this Chigrocha is obtained, and all that he explains in great detail. My feeling is that much of it is somewhat thought experiment. Much, okay? Because they are so, quite complicated, and it would have been very difficult to make those observations. But still, there may be some things which is worth repeating, okay? He says that to find out the Mandocha for moon, he says, keep on observing every day and get at that day in which the rate of motion is slowest, okay? And then that position of the moon is the position of the Mandocha itself. See, this is something worth trying. One can do that, okay? So, and also he describes some various instruments and all that. He has given one Falaka Yantra, that is his own invention. He is immensely proud of that in his Goradhyaya. So that can be done. In fact, I had done some crude experiment on Falaka Yantra. You see, it's very good. So these things can be, straight away one can verify it. And he talks of all the, in the beginning with, when he begins the text, he says, I, greatly, very, with a reverential attitude to the old astronomers, the ancient astronomers, these predecessors, Acharyas. Brahmagupta, he has great admiration for Brahmagupta. He calls him Ganaka Chakra Chudamani, okay, and then Varahamihira, and many others also, you see. So he says all that, okay, and then, then he says that these people have done very wonderful works. So they are great, brilliant works. But why there is a need for a work by me? So he says that in a very polite but very firm fashion, वो तो सही है, they have done all that, but there are certain questions which they are not answered properly. There are some issues which they are not considered. So to make it complete, we have to do all that also, to advance it, to give it, to bring it to a level of perfection. So this also we have to do, he says, and and then he keeps his word, and he says that please read my work fully. Don't say, don't see one or two adhyayas and say, oh, these are all their earlier things, Please, krutsnam, the whole text you read, and then come to the conclusion about, whether I am saying some new things and all that, whether I got some interesting things. So he does that. He has questions. Brahmagupta, the great Brahmagupta, whom he admires so much, many ways, he says, Brahmagupta is wrong here. I will know, you have to change this thing. And this Lalla was, I think, a very famous person at that time also, in 12th century. So he is he seems to have a love-hate relation with him. Okay, because he has written a Vivarana on Shishadi Vrududha of Lalla. Okay, so it's considered important. But he says, many things he has, completely botched up. He has, not said the correct thing. So Lalla is very critical at various things. For many things, he says, Prakarantarena. I have derived this result, I have given this result. Let me try one more method to give this. You see, that is there in many places, that he does. And then he says, for finding, some zenith distance for arbitrary directions, arbitrary locations, the azimuth, okay. He says that previous acharyas have tried this and tried that, but that is not general. Now I am taking up the general issue. And then, he gives this thing, okay. And he gives, moves forward this spherical trigonometry quite a bit, though not the modern thing, but his insights, geometrical constructions are great, really it is educative. Even if you just give a course in Siddhanta Shiromani, it is worth it even for modern audience, okay. So all these things he does. One thing which I liked was that, rate of motion of planets, okay. Rate of motion of planets, which is a complicated thing, okay. Because he knew how to do the derivative, sine function he knew. Sine inverse aa jata hai. And sine inverse of ratio of two functions. So that would have been difficult, but he said that this is difficult. But so we should try an entirely different method as told by somebody. I could not locate where these things, He may not be the first, I don't know. He says that. And then he gives an entirely different method which is exactly correct in his framework. I mean, it may not be the correct formula, but it's exactly correct in his framework. Retrograde motion of Vakya-s and all that, he gives the thing. And similarly, he talks about, this cosmology. He says that, some people say that universe is boundless. Some people say it's finite. How can we say that? I don't know. I cannot say that, The people have made some definite views, but my opinion is that one can't give the answer. So I mean, it's complete. If you take a scientific nature of Indian astronomy, you have to read Bhaskaracharya's thing. It will come in. Apart from, of course, it was superseded by many other things and systematization and all that, So all these things make it very. Of course, he was profoundly influencing the later things. I think Kerala mathematicians, astronomers were. Of course, he is a great one in. That he is a author of Leelavati and Bijaganita. His work was so awesome that somehow people, I think, were somewhat psyched, by his thing, how can we write something more kind of a thing. So, but then, in mathematics you have this Narayana Pandita who greatly expanded this Leelavati, called Ganita Kaumudi, which is 3 times the length of Leelavati, okay. So, and it is significantly very new important results and all that, In astronomy, there may be others also, one has to check that. Certainly he has an influence always, to all the later astronomers, certainly Kerala astronomers and all that, this Nilakantha and all that would have been influenced by Bhaskara's way of thinking, and because all this is drawing of circles and all that which he explains, so that they do. And the general results in spherical trigonometry, Triprashna problems and all that, of course, much more is done in Kerala and Yuktibhasha and all the spherical trigonometry, apart from planetary model. Spherical trigonometry also has a great amount of advancement is there in this thing, and that is, Bhaskara almost comes to that spherical trigonometry, but he can't, because maybe our times. So he has a definite influence on that, okay. But in general thinking, that, you have to explain these things properly and things like that. Yeah. So that is how this Bhaskara's influence permeates. Even now, people are influenced by him. Yeah.
Thank you very much, sir. So we have been talking about a lot of texts and concepts briefly. So question arises as to how can we improve the research in history of science in India?
Yeah.
That is one general part where if you can enlighten us a little bit about what kind of manuscript work needs to be done in that area, that will hopefully give some idea to people who are looking at what can be done, because learning the earlier works, propagating it, doing research is needed. That is one part. There are others which need to be published also, right? So can you explain us a little bit?
Yeah. So I think that is true. I mean, one has to do some original work and all that. But the main thing, and especially nowadays, there is a huge amount of talking, on Indian knowledge systems and all that. Lot of people have taken projects and lot of new centers have happened, come up and all that. You see, that's a very good thing. But I think some amount of many. I have not myself been part of this review exercise. Some of my friends and colleagues, so they have looked at these project proposals and all that. So they say that many of them are not, really good, not very of good standard. They're substandard kind of a thing and all. One should have for history of astronomy method and history of science in general, one should have, see, nobody can look at some manuscripts and all that, immediately. See, it looks very fascinating to say, oh, I've entered this field, I'm looking at this manuscript and all that. Nobody can, not many people can understand, just like, by looking at them and starting with some manuscripts. One has to have a lot of background, okay? So the background information has to be given to all the people who are seriously working in Indian. For instance, if somebody works, PhD in, let's say, physics, nobody goes to, when they join the PhD program, he will not, or he or she will not go and read some papers and start working on some research problem. They have to already, they would have done enough huge amount of background material in physics in their BSc, MSc and all that, you see. In physics, they should know classical mechanics, they should know quantum mechanics, they should know mathematics. All these things, they should have a good training. So some regular coursework is needed, kind of a thing. And that's what many people have. In fact, IIT Kanpur, when I was a PhD student, they had a very good program for courses, So they knew that many of the people, MSCs from other places, their background was not that good. So they have made them go through some 1.5 years of coursework, So that is an important thing. So similarly here, for all history of science, Indian knowledge system in general, I will say that, there must be coursework for 1.5 years, One should not expect any output from them, you see. That is my personal opinion. If somebody is very brilliant, then it's okay. One can always do, he or she can always do nothing to it. But they should have a very good background, you see. Like somebody, even if somebody wants to do mathematics, he should know astronomy also, mathematics also, and also he should know something about, Indian architecture. He should know something about music, okay, because music also, this mathematics is applied. He should know something about Ayurveda, you see, because some principles are still there, you see. So all these things, they should have uniform, they will have good coursework for all the people, for all persons who are working in history, or Vyakarana, if they want to do this, And I see that there are too many, there are some people who are, taking up too many projects, okay, and which I have a feeling that they are not able to devote lot of time to each student, you see. So that also is a matter of concern, okay. So then they are on their way, on their own, and because of lack of experience, there may be a lot of waste of time. So one has to systematize this Indian knowledge system thing, Some of it may be even national level courses, you see. That is what used to be done in modern, I know physics and all that, some particular topics, what are the CERC schools, some DST and all these people, they're CERC schools. CERC school means, suppose you want to talk some topic in nonlinear dynamics, okay? So everybody can't have persons working in nonlinear dynamics at a high level in each university. So all the people, there may not be more than 30-40 people working in India on that topic, 50 people. So they will all be collected at some place, and then they will be given lecture by experts, the PhD students, research scholars and all that, you see. All over India, lecturers from all over India, students from all over India, you see. So they will get some expertise in these things. See, some kind of some structured, we should have some structure of, making more effective use of the certainly available knowledge and available, enthusiasm and available brightness of the people, young people. You should channelize them properly, and then only they can, because if you ask them to give some output, after 1 or 1.5 years, they will not be able to do it, and they will tell some, they will claim much more than what they are done. You see, that's what happens in science regularly. So that should be there. Some training must be there. And what is the second part?
Yeah, it was about manuscripts.
Yeah.
What
So
are
manuscript,
there?
of course, they can, we have, see, in fact, you may be surprised to know that myself, Srinivas and Ram Subramaniam, we didn't look at any manuscripts for quite some time. For 10, 15 years, we didn't look. Because already many things are available in print, which are left, which are there to be explored. Nobody has thought about it, nobody has analyzed it, Like Tantrasangraha, it had been published quite some time back when Surnath Kunjan Pillai and then K.V. Sharma also, and some commentaries and all that. Yuktibhasha also was fairly well known, you see. But the thing is that, so the manuscript part was done by K.V. Sharma for this Yuktibhasha. He did the thing, and he consulted, and he gave an authentic edition, he gave the translation, we provided the explanatory notes. So Karanapaddhati also was it was known. Afterwards, we are now looking at some manuscripts, okay. So there is one, this is called Lagna Prakaranam, okay, we thought that that is by, supposed to be Madhava. So that was there, in some manuscript libraries, even in our K.V. Sharma Foundation. So that is a manuscript, a new manuscript we are looking at, So, and then one Drukkarana, Professor Pai is looking at it. Drukkarana is also another important text, Malayalam text on this thing. So we are looking at it at the manuscript level, okay? And then of course translation and explanatory notes, etc. will be there. So manuscript level are going on. And so many more people are doing. Even IIT Madras, there are some people who are looked at some new manuscripts of Brahmasphutasiddhanta with fuller commentaries of Prutudaka Swami and all that, you see. So this thing is going on, but as I told you, the preparation is very essential, and then you can go to.
Thank you, sir. That was very enlightening for us, because in a rush to do something new, we don't get prepared very well.
Yeah.
So that point, I hope everyone takes it very seriously. Thank you for your time today.
Thank you.
Now,
And thanks a lot for giving this opportunity. It's also I could think over various things happening.
in fact, when you answered some of these questions, general principles about how to go about thinking with respect to science, development of how it happened, developed, etc., also came into picture, because that is something we grapple with these days.
Yeah.
Because people glorify, some people completely denounce.
Yeah, exactly.
So there is a balance, and
Yeah.
how people have scholars have dealt with,
Yeah.
came up in your answers. Thank you very much.
Thank you. Yeah.
So the next part of the program will be. Questions.
Sir, thank you very much for guiding us, sir, specially. I am following you since last 10 years.
Oh, thank you.
You have started that course on NPTEL platform, sir.
Yes.
And also,
Yeah.
both complete
Yeah,
team,
yeah.
sir. I have gone through your published works and research paper also, sir. Being a student of physics, sir, I want to know, by exploring the applied physics part, that is the astronomy, can you please guide us with respect to physics, how we can start, or what are the resources or research work done by our past scholar available, sir?
See, physics itself is, I am not that familiar. Okay, some amount of physics is there. It comes, like this Vaisheshika, these things, Kanadas, Vaisheshika Sutras. Some kind of a physics does come and all that, So that is the only thing. So, but beyond that, one has to look at them, what they have done, and it is a tough thing, because even in Europe and West, the so-called physics got a tremendous boost only after, Galileo and all that, you see. After Kepler, till Kepler, it is almost mostly astronomy. Galileo was the person who was, grappled with what can be called as physics problems. Of course, before that, Aristotle was there, okay, but that was mostly thinking only, you see, not related to this. Because this physics involves this, as we understand today, physics means force, acceleration, and that kind of thing, So those concepts are not there in this thing. So, but some amount of preliminary things were there, okay, that impetus and impulse and all that. Uh, Kanada has made some observations. So, in fact, Professor Srinivas is more competent to say about that. So, so that kind of a thing is there. But beyond that, but one thing is instruments. Yes, instruments one can explore. Using this Indian method, at least for astronomical instruments and all that. You see, so that can be time-keeping devices and all that. So that can be probably one can get some inspiration from this thing.
Can you say something? No, you see, the modern science of mechanics itself is a product of development in astronomy. Newton's thinking here solves basically problems of planetary motion, celestial mechanics. And this has been very well documented by Weinberg, who has written a history of physics, a booklet of around 300 pages, where he explains how mechanics arose out of astronomy. And Indian astronomy was very well suited for this transition, because the Greek astronomy was stuck with the geometrical pictures. There were no formulae, there were no equations, there were no analytical models. Even things like velocity, the concept could not be easily done without formulae. And Indians started moving from there. They had formulae, of course these formulae were written in, or equations, they were written in terms of verses, but they could easily convert it because they knew algebra also. So both things developed in India in 5th, 6th century. And for every astronomical sort of phenomenon, be it the length of daytime, or the rising point of the sun, or the relation between the declination and the longitude, we all had formulae for that. And now once you start treating the motion as a function of time, then the idea of speed, velocity immediately comes. And by the time of Munjala and Aryabhata too, they had the idea of instantaneous velocity, that the change in displacement goes like a sine function of time, and the velocity goes like the cosine function. And Bhaskara has explained it very fully in the idea of Tatkalika Gati in his Vasana Bhashya of Siddhanta Shiromani, which Professor Sriram has explained fully in his. So this velocity, instantaneous velocity, with a calculus kind of a background, originates with Bhaskara, and it's dealt with in much greater detail in the Kerala school. That Nilakantha, since sine inverse function comes, he comes with its derivative 1 over square root of 1 minus x squared for the velocity. Then in the mechanics direction, so this, whatever are the basic inputs are there already, so velocity is changing. Therefore the idea of change of velocity is there. And many models, even planetary models, give some constant acceleration kind of changes and see what happens. That is there in very old Siddhantas like Vasishtha-Siddhanta. We will see that later. But in the other side, from the Vaisheshika side, what came was what causes motion. Motion is called karma there. And how this karma is maintained or changes. And that problem which Aristotle could not solve, because Aristotle thought that for motion to continue, you need to have continuous force applied on something. But in Vaisheshika Darshana, starting from Kanada, later on Prashasthapada Bhashya, there are very detailed discussions of all different kinds of motion. And where this is understood, for motion to continue after it has begun, from rest to change, you need some force, nodana. But afterwards, the motion itself has some property which continues itself. So that was called Vega. Today we are translating Vega as velocity, but Vega is what is called impetus in older science. It is more akin to momentum. And so this idea is there, a very clear understanding of first law of, in a qualitative terms, that motion can continue without any external force because the Vega is there. And this samskara of Vega is what carries the motion. And further force will change this also. So all this is discussed. This starts in Europe only around 14th century in Oxford and in Paris by various philosophers. And so the old idea of Aristotle is criticized. There were some people in Greek tradition also in 5th, 6th century who criticized Aristotle, but they could not come up with this idea. So in 14th, 15th century, this is what sets into motion new understanding of mechanics. And then it goes into Galileo and goes into Newton. We have not studied what happened after Prashastapara in Indian tradition, but those discussions are mostly qualitative amongst the published works that I have seen. But in astronomy, it's all very quantitative. They are discussing. So even 3 axes and how to locate a celestial body is all there in Nilakantha, in Jeshtadeva and all that. So there are many, many ideas which are at the basis of modern science of mechanics are there in, but they would never talk of some universal laws or things like that. They would analyze a motion and give it a mathematical formulation, and then if it's applicable in another case, they will take it to that case also. So like that it would go on. So we had a lot of interaction between astronomy and understanding of motion, and the other understanding of how motion is maintained by itself due to momentum and force changes that is there in the Vaisheshika Nyaya tradition.
Perhaps should have mentioned is that formulae. The formula in terms of slokas are there, in Indian astronomy. See, that is, if you want to consider so that is what made them look at instantaneous velocity and things like that, because if you have a formula for the position, then, you can say how does it change? How does it change from day to day? And if you know how to change from day to day, then you can find out also how it instantaneously change. So that is how this concept of calculus, etc. is there. In Indian, it's developed there, you see. So because of the formula. So that is something which is Western intellectual establishment doesn't talk about it at all, which makes it much direct, whereas in, or for the duration of the day, you see, what is the duration of the day? How do you calculate it? India has a different formula. So some of them are precursors to the modern way of expressing things. So that is a very important thing. Okay. Yeah, this cosmology also, it doesn't come in astronomy text much in the Nyaya Vaisheshika school and all that, So it is very striking that many of the things are very there already, like in the modern astronomical, cosmological concept is that, which everybody is knowing, the Big Bang theory. And at the beginning of the Big Bang, everything is in a state of dissolution. Okay? This is all in terms of fundamental constituents only. They are not formed and all that. Exactly similar theory is there in Vaisheshika Sutra. You see, all of them are in form of these anus and paramanus. You see, all of them that state, and then only they will combine and all that. They also give some qualitative descriptions of how they combine and things like that. You see, so that way it is there. Okay, but as you said, it is very quantitative, and very striking that Kannada thinks of space as also as matter, as one of the dravyas. So that kind of some advanced thinking was there, but it was some kind of a qualitative thinking. So if it had moved more, maybe we could have also got many, could have progressed further,
सूर्य सिद्धांत बहुत प्राचीन है, उसके बाद 5 सिद्धांत हैं, उसके बाद आर्यभट्ट भी है। आपने भी बताया भास्कर ने कई सिद्धांत उदयांतर संस्कार, बीज संस्कार बताए भी, पर 200 साल के बाद ही गणेश देवक ने उनको ओवरलैप कर दिया। फिर उसके 100 साल बाद कमलाकर भट्ट ने सूर्य सिद्धांत को फिर ले आया। आज के डेट में भी सिद्धांत के अनुसार जो पंचांग बनते हैं उसमें भास्कर के साइंटिफिक एस्पेक्ट को हम लोग प्रयोग नहीं करते, क्योंकि पंचांग को पारंपरिक रूप से या तो उनकी श्रद्धा प्योरली सूर्य सिद्धांत में है, या उनकी प्योरली श्रद्धा सामंत चंद्रशेखर में या वेंकटेश के केतकी ग्रह गणित में है। तो कहीं ना कहीं ये बीच का जो 1000 ईयर्स जो ये काम हुआ, भास्कर का हुआ, कमलाकर का हुआ, क्या भास्कर का जो काम था उसको प्रैक्टिकली हम पब्लिक तक पहुंचा पा रहे हैं, या उसके लिए कुछ काम हुआ है या कर सकते हैं कुछ थोड़ा इस पर?
In fact, Bhaskara has also be considered, they did that, that analysis, accuracy and this thing. So Bhaskara, see, in practical terms, it was not that, great advancement, Bhaskara. His theoretical ideas and way he put things and all that, whereas in parameters and all that, or in actual calculation, it may not improve much. That's the thing, और सूर्य सिद्धांत तो है वो जो अभी मानते हैं, मतलब उसको when they do that. But I think it's called Modern Surya Siddhanta. Most of the scholars say it's Modern Surya Siddhanta, which was composed around 9th century or so. पता नहीं हमको. I mean, प्राचीन सौर सिद्धांत जो है वो परामीर ने भी समराइज किया है ये. बट व्हाट वी इज देयर जो प्रचलित है वो कुछ 9th-10th सेंचुरी का कहते हैं शायद. या सो दैट इज देयर. सो देयर उसको दैट्स व्हाट एज आई सेड some parameters have to be changed, some new terms have to be added, but within the framework, So probably some Chandrashekhar Singh Samanta approach may be this, just a rough impression I'm saying. Oh, Surya Siddhanta bhi kar sakte hain, but they are not very different. Only Chandrasekhara gives some more corrections and more this thing and all that, So एक बार ये parameters को revise कर दिया, so तब तो the major work is done. So बाद में जो कुछ additional correction term जो करते हैं, that can be, it can vary also.